Welcome geniuses, I'm Genie, your best buddy for A-levels. In this channel, we'll bring you to explore the secret formula behind success.
Hi everyone, I'm Xianjing, your further maths tutor. Today, we will learn about how to solve the roots of polynomials. It is the first chapter in the further maths CIE A-level syllabus. The roots of equation can be solved using substitution method, which works most of the cases, but not all. So, mathematicians came up with a method known as the sum of roots method to solve the root of polynomials. Let us now look at the theory of the sum of root methods. Suppose we have ax squared plus bx plus c, and the roots are alpha and beta. And we can rewrite the equation like this. X squared plus boax plus coa. And it can be equivalent to x minus alpha times x minus beta. And it is equal to x squared minus alpha plus beta times x plus alpha times beta, and equals to 0. Okay. So now we know by comparing both equations, alpha plus beta equals to minus BOA, whereas alpha times beta equals to C over A. Now let us focus on the next one, cubic equation. Suppose the root of the cubic equation is alpha, beta, and gamma, then you can rewrite this equation to become x cubed plus boax squared plus coax plus doa. And this is equivalent to x minus alpha times x minus beta times x minus gamma. And we now expand the equation to become x cubed minus alpha plus beta plus gamma times x squared plus alpha beta plus alpha gamma plus beta gamma times x minus alpha beta gamma, and this will equals to 0. So we now can, by comparing both equations, says that alpha plus beta plus gamma equals to minus b over a, and alpha beta plus alpha gamma plus beta gamma equals to c over a. And finally, alpha times beta times gamma equals to minus d over a. Alright, let us now move on to the quadratic equation with the roots of alpha, beta, gamma, and delta. Now we rearrange it to become x to the power of 4 times plus BOA times x cubed plus COA times x squared plus DOA times x plus EOA. And this is equivalent to x minus alpha times x minus beta times x minus gamma times x minus delta. which is equal to x to the power of 4 minus alpha plus beta plus gamma plus delta. Okay, times x cubed plus alpha beta plus alpha gamma plus alpha delta plus beta gamma plus beta delta plus gamma delta. Okay, times x squared and plus alpha times beta times gamma plus alpha times beta times delta plus alpha times gamma times delta plus beta times gamma times delta times x plus alpha beta gamma delta. And equals to 0. So we can say that the sum of alpha, which is alpha plus beta plus gamma plus delta, equals to minus BOA. Whereas sum of alpha times beta equals to COA. And the sum of alpha times beta times gamma equals to minus DOA. And the product of alpha, beta, gamma, delta equals to EOA. Now, let us look at some examples. Let's look at question 1. The equation 3x squared plus 2x minus 7 equals to 0 has the roots alpha and beta. Find the equation whose roots are alpha squared and beta squared. I'll show you two ways to solve it. The first one is substitution method, and the second one is the sum of roots method. So now let us look at the first one. So we let y equals to x squared, and then x equals to the square root of y. Next, we substitute it inside the equation, so we get 3y plus 2 square root y minus 7 equals to 0. Next, we rearrange the equation to become 2 square root y equals to 7 minus 3y. So, by squaring both sides, we will get something like 4y equals to 7 minus 3y squared. And by expanding this equation, we will get 49 minus 42y plus 9y squared. And hence, rearranging the equation, we will get 9y squared minus 46y plus 49 equals to 0. And that is the equation that we want to find. Let us now try the other way to solve this, the sum of root methods. So now, let us use alpha prime equals to alpha squared, whereas beta prime equals to beta squared. Then, alpha prime plus beta prime equals to alpha squared plus beta squared. And we know that alpha squared plus beta squared equals to alpha plus beta squared minus 2 alpha beta, something you have to memorize. So from the equation above, we know that the sum of root alpha plus beta equals to minus 2 over 3. So minus 2 over 3 squared minus 2 times the product of roots, which is minus 7 over 3. And typing those values into calculator, we will get a value of 46 over 9. Up next, we'll look at alpha prime times beta prime, which is equals to alpha squared times beta squared. And it is also alpha times beta squared. And alpha times beta squared equals to the product of root, which is minus 7 over 3. And you square it, you will get 49 over 9. Now have both the new sum of roots and product of roots. We can now plug them into the equation by writing x squared minus 46 over 9 x plus 49 over 9 equals to 0. And we got the equation similar to the substitution method. Let's now move on to question 2. The equation x squared minus 7x plus 3 equals to 0 has roots alpha and beta. Find the equation which has roots alpha plus 2 beta and 2 alpha plus beta. First of all, let us look at substitution method. In order to use substitution method, it is necessary to use the fact that alpha plus beta equals to 7. So the first root, alpha plus 2 beta. And we can rewrite it as alpha plus beta, and which is equal to 7 plus beta. Also, the second root is 2 alpha plus beta, which is equal to alpha plus beta plus alpha, and it is equal to 7 plus alpha. Thus, it can be seen that all is required is to find an equation which has the roots alpha plus 7 and beta plus 7. Using the substitution, y equals to x plus 7 in the equation of x squared minus 7x plus 3 equals to 0, we can rewrite this equation as y minus 7 squared minus 7 times y minus 7 plus 3 equals to 0. And we can further simplify this into y squared minus 21y plus 101 equals to 0. And we get the answer. Let's now try to solve this equation using the sum of root methods. So we first let alpha prime equals to alpha plus 2 beta, and beta prime equals to 2 alpha plus beta. Then we will have alpha prime plus beta prime equals to alpha plus 2 beta plus 2 alpha plus beta. And we can rewrite this equation as 3 times alpha plus beta. And we know that alpha plus beta is 7, so 3 times 7 equals to 21. Next, we solve for alpha prime beta prime, which is equals to alpha plus 2 beta times 2 alpha plus beta. And we can rewrite this equation as 2 alpha squared plus 4 alpha times beta plus alpha beta plus 2 beta squared, which is equals to 2 times alpha squared plus beta squared plus 5 times alpha times beta. And we can rewrite it again, since we know that alpha squared plus beta squared equals to alpha plus beta squared minus 2 alpha beta. And then we can solve this equation into a simpler form, which is 2 times alpha plus beta squared plus alpha beta. And we know that alpha plus beta equals to 7, so 2 times 7 squared plus 3, and we can get 101. So plugging in all the numbers, we can get the desired equation, which is x squared minus 21x plus 101 equals to 0. The two equations that we just solved were quadratic equations. So in order to solve problems involving polynomials of a higher order, we need to remember the following notations. Let us first look at the cubic equations. Suppose that the sum of alpha equals to alpha plus beta plus gamma, and the sum of alpha times beta equals to alpha times beta plus alpha times gamma plus beta times gamma. So there are a few keys that we need to remember. The first one is the sum of alpha squared, which is equals to alpha squared plus beta squared plus gamma squared. And we know that it can be equals to alpha plus beta plus gamma squared minus 2 times alpha beta plus alpha gamma plus beta gamma. And we can rewrite this as the sum of alpha squared minus 2 times the sum of alpha times beta. And you need to really memorize this. The second one you need to remember is the identity of the summation of alpha squared times beta squared. So I'll show you how to derive this. It is equal to alpha times beta plus alpha times gamma plus beta times gamma squared minus 2 times alpha squared times beta gamma plus alpha times beta squared times gamma plus alpha times beta times gamma squared. Next, we can rewrite this whole equation by factorizing out alpha, beta, gamma, as you can see in this equation. Okay, now we will have the most simplest form, and we can rewrite this as the sum of alpha times beta squared minus 2 times alpha times beta times gamma times the sum of alpha. And this is the second equation that you need to memorize. Now, the final one, sum of alpha times beta times alpha plus beta. So we can rewrite this as alpha times beta times alpha plus beta plus alpha times gamma times alpha plus gamma plus beta times gamma times beta plus gamma. Okay, now we will make each of the bracket having all three alpha, beta, and gamma. Since we are adding each new term inside, we will have to minus them back. So at the end of this equation, we need to minus 3 times alpha times beta times gamma. Alright, now we have the three similar terms of alpha plus beta plus gamma, and so we can factorize it out, and we will get alpha times beta plus alpha times gamma plus beta times gamma, and times alpha plus beta plus gamma minus 3 times alpha times beta times gamma. and further simplify them into sum of alpha times beta times the sum of alpha minus 3 times alpha times beta times gamma. And this is the third identity that you need to remember. Now, let us move to the quartic equations. And I will not show you the derivation because it will be really troublesome. So just remember the few identities. But before that, let us look at the few terms that you need to know. Sum of alpha equals to alpha plus beta plus gamma plus delta, since quartic equation has got 4 roots. So next one is the sum of alpha times beta, which equals to alpha times beta plus alpha times gamma plus alpha times delta plus beta times gamma plus beta times delta plus gamma times delta. And the third one to remember is the sum of alpha times beta times gamma, which equals to alpha times beta times gamma plus alpha times beta times delta plus alpha times gamma times delta plus beta times gamma times delta. Okay, now the 3 identities to remember. The first one is the sum of alpha squared, which is surprisingly the same as the cubic one, which can be rewritten as the sum of alpha squared minus the sum of alpha times beta times 2. And the next one to remember is sum of alpha squared times beta squared is equivalent to the sum of alpha times beta squared minus 2 times the sum of alpha times beta times gamma times the sum of alpha minus 2 times alpha times beta times gamma times delta. And let's move on to the third one. It's the summation of alpha times beta times alpha plus beta. And this is equivalent to the sum of alpha times beta times the sum of alpha minus 3 times the sum of alpha times beta times gamma. To bear in mind that it is actually quite unlikely to meet quartic equations in the exam.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with 1 or 2 past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.